The Paxos algorithm consists of three roles: proposers, acceptors, and learners. Proposers propose value to be chosen by the system. They select proposal numbers and send, prepare, and accept requests to acceptors. Acceptors vote on the proposal from proposers. They keep track of the highest proposal number they have promised and highest proposal number with an accepted value. When they receive a prepare request with a higher proposal number, they promise not to accept any other proposal with lower numbers. When they receive an accept request for a proposal they have promised, they accept the value and respond with the accept message. Learners learn from the values chosen by the system. They query a majority of acceptors to determine the highest accepted proposal number and its corresponding value. The core Paxos algorithm then works as follows. The proposer selects a new proposal number n and sends the prepare request with the number n to a majority of acceptors. Acceptors that have not promised a higher number proposal n by sending a promise response. If the proposer receives a majority of promises, it chooses a value v and sends accept request for n of the acceptors. Acceptors then promise proposal n and have not accepted a higher number proposal, accept the value v and respond it with an accept. If the proposer receives a majority of accepts, the proposal is chosen. The learners can then learn the chosen value v by querying a majority of acceptors. If the proposer does not receive a majority of promises or accept, the proposal is not chosen. The proposer can then try later with a higher proposal number. This allows multiple proposers to propose values in a decentralized system with values chosen in a consistent total order through the proposal numbers. This is a Python program that implements the Paxos algorithm, consensus algorithm that is used to agree on a single value among a group of distributed nodes. The program defines a node class that defines a node in a distributed system. Each node has a unique ID, a message, a promise count, a accept count, a list of peers, and flags indicating whether it is accepted and committed a message. The app variable creates a Flask web application instance that can be used to serve HTTP requests. The timestamp and total variables are used to keep track of the current timestamp and the total number of nodes in the system respectively. The latest message variable is used to store the most recent message received by the system. The agreement values list contains the values that the nodes can agree on, and the logs list is used to store the system logs. The node class has several methods for implementing the Paxos algorithm. The init method initializes the node with a given ID and sets the other variable to the default values. The set peers method sets the node's list of peers to the given list of nodes. The status method prints the node's current status, including the ID, timestamp, promise count, accept count, and message. The propose value method is used to propose a new value to the system. It generates a new timestamp, sets the node's message to a proposed value, then sends the proposed message to all its peers. The send proposed message method sends the proposed message to each of the node's peers. The send message method message method sends the message to the peer with a random delay of 20% probability of dropping the message. The receive proposed message is called when the node receives a proposed message. It is message timestamp is greater than or equal to the system's current timestamp. The node sends a promise message back to the sender. The receive promise message method is used when a node receives a promise message. It increments the node's promise count and sends an accept message to all its peers if the promise count is greater than or equal to half of the total number of nodes in the system. The send accept message method used accept message to each of the node's peers. The receive accept message is called when the node receives an accept message. It increments the node's accept count and sends an accept message to all its peers if the accept count is greater than or equal to half the total number of nodes in the system. The receive accepted message is called when the node receives an accept message. It increments the node's accept count and sends a commit message to all its peers. If the accept count is greater than or equal to half of the total number of nodes in the system, the receive commit message is called when the node receives a commit message. It sets the node's committed flag to true and updates the system logs.
Hello everyone. So now we'll actually look into how we've implemented the Paxos algorithm. Uh, this code snippet right here renders the front end that we're going to see in a minute. And this is exactly how we are exchanging information between the front end and the back end. We'll quickly look into how the front end has been made. So this is the front end, and you can see these circles, 10 of them, each 10 of them being a node, which will actually request the others, which will actually propose the other receivers for a value, right? So if I click on this button, submit, it sends a proposal value to the other nodes and actually receives accept messages, and then the quorum is established or maybe not, right? So this is happening using this function where data is a variable that takes in what we've clicked on the front end, and then that is passed to this propose value function that we have implemented above in this class known as node, right? And then whatever the result is returned to the front end using this function. So if we click on 7 and 2 at once, these are the proposal messages and the receive accept messages that will be received, and the quorum will accordingly be established. And this is the index.html, that is the front end file that we've made, which includes these 10 buttons and their styling. And this is exactly where the input is taken and then passed into the backend which we've made in Flask. So for each number that we press, there's certain functions that are being run and executed, and this is how the output is put into the front end that we've seen. Thank you.